In this module 8, we will learn how to use advanced feature. We will discuss how to create swept boss base and swept cut. Then we'll see what is loft boss base and loft cut. Similarly for boundary features. And lastly, we are going to learn how to use standard holes. And lastly, we are going to learn how to use standard hole features. Now creating swept boss base and swept cut, you require a path and a profile. Swept boss base feature create 3D solid by moving a 2D profile along a path. So look at this object. Here we have ellipse as a sketch and this arc as a path. So here ellipse will be simply follow the path and create the solid. So in sweep, the section remain constant, that is a sketch geometry. Now use swept boss base when the part has constant cross section and follow a non-straight path as explained just earlier. So what you can create using this swap base, you can create pipe, tubes, springs, handles, cable routing, rubber seals, wires. Now remember, you require a profile and path. Now path can be existing edges of face or you can the sketch path. It will work. Now let's discuss the property manager of swept boss base. Here the first thing is profile and path. You have two options. Either you can use sketch profile or directly SolidWorks has given a circular profile options. So it is very useful to create the pipe and tubes. After that, we have to discuss the guide curves. What is importance of guide curves? And likewise, as we move through the exercise, we will discuss various options. Then the start and end tangency and the curvature display. We'll try to explore all of these options through exercise. Now sweep must follow these rules. Please remember this, otherwise you are not able to create the swept features or it will throw you error. Profile must be closed for a base or boss swept feature. Profile must be open or closed for surface sweep feature. So this will create a solid part. This will create the surface part. Path may be open or closed. It can be like an arc or it can be completely circle or ellipse. Path may be a sketched curve, contain one sketch or curve or set of model edges. For example, it like a line segment, then arc, or there can be some more lines. So in a single sketch, then can be multiple say a sketch segment, or you can choose the edge of existing model. So this model edge can also be work as a path. Now there is a requirement, path must intersect the plane of profile. This is very important. If it is not satisfied, you are not able to create the sweep feature. Neither the section, the path, or nor the resulting solid can be self-intersecting. For example, you cannot use path like this because it is intersecting. Even if you create a sweep feature and it is just crossing its own body, then it is also not allowed. Now guide curve must be coincident with the profile. Remember, here it is very clearly written coincident with the profile or with a point in the profile sketch. Otherwise, you cannot use the guide curve options. We'll see in detail what is difference between the path and the guide curves. Using exercise 8.1, we'll try to create object like this. Here we will explore how to use circular profile. You can also create a thin features, or I mean to say a hollow tube. Now open the exercise 8.1. Here I have created a sketch on a front plane. Now let's go to feature and click on swap boss base. We will use circular profile options because we already have a path. Now SolidWorks is customizing the experience of SolidWorks. So many time user are requesting this feature that why don't you provide these circular profile options instead of a user has to create a circle over here. So as an improvement, they have added this circular profile. Now if you look at this icon very carefully, it says that once you choose this profile option, you have to choose the path. So this icon indicate path. So we are going to choose this sketch. Moment I choose, it'll give you some preview. Here diameter value we have kept to 10 millimeter. If you wish, you can simply increase the value. Go ahead and click OK. So this way, using simple circular profile option, you can create a tube like a shape. Now let's delete this feature. Once again, start the sweep features. This time again I will use circular profile and 10 millimeter diameter options. Instead creating the solid geometry, I will choose thin features and I will add 1 mm thickness. Now if you want to add thickness inside and outside, you can control through this toggling button, that is outside thickness and inside thickness. Now go ahead and click OK. So this way, simply using circular profile, you can create a hollow tube or solid tube. Now in exercise 8.2, we are going to create a part like this and profile like this. But here, instead of using circular profile options, we will use sketch profile options. That is, we have our oven sketch. So create new part file. Make sure the dimensions are in millimeter. This time I'm going to start the path on a right plane. It's a very simple geometry. You can refer the slide. Now let's add the dimensions. So this is 140. This is 40. Now let's add the corner radius. So this is one corner radius and second corner radius. Now let's click OK and exit. So path is ready. Now we want to create a profile. So profile plane, as per the requirement rules, the path must intersect the plane of profile. So we need to create a plane. So choose this endpoint, press Ctrl and select this and go over here and choose the plane. It will place the new plane perpendicular to selected line and passing through this endpoint. This is what exactly we want. So click OK. Now open the sketch. Now this time I'm going to add center point rectangle. Here the dimension is 10 and this is 20. Now go to feature command manager and click on the swap feature. Here we will use option called sketch profile. So this is our sketch profile. So select it. Now we have to choose the path. This time I will choose this as a path. Now look at the preview and click OK. So we have created a door handle. Now let's edit this part. So instead of this sketch, let's try to change sketch in a different way, or try to change the geometry of a sketch. So select this entire sketch and convert into construction geometry. Now let's add a circle and diameter equal to, let's say 15. Now let's exit. So instead of that square or rectangle profile, we are able to create a circular handle. So you can edit the sketch profile at any time, but make sure this path is coincident with the plane of a profile. Otherwise, you are not able to create the sweep feature. In exercise 8.3, while creating sweep feature, we will use existing edges of a part as a profile. Right? So SolidWorks allow you to choose this surface and that will pick up the entire outside edges and create its profile. So let's switch to SolidWorks and try this exercise. Open the exercise 8.3. Here I have a one extrude feature and I have drawn one path. Now go to feature and click on sweep features. Choose the first option, sketch profile. Now I do not have a sketch profile. Instead, I will choose this top surface. Now second option is to choose the path. I will choose this path. So SolidWorks simply choose the edges of this face as a sketch profile and then sweep it along the selected path and click OK. Similarly, we'll try 8.4 exercise where we have a plastic part. We will use the outer edge as a path and this sketch profile as a simply the area to sweep along. Now, because of this exercise, we are able to experience this option called tangent propagations. So because of these options, the profile will simply continue with this line segment to this arc segment because both are tangent to each other. So let's try in SolidWorks. Open the exercise 8.4. Here I have a plastic part and this is the small sketch profile which is drawn on this plane, right plane. Okay. Now go to command manager and click on swept boss base. Here I have to choose this sketch profile and this time I will choose these options. Now see what happened here. Moment I choose it, what it does, it simply, because it is exactly at the middle, it offer you other options which is not available in previous exercise. So either you can sweep on a one side which is called direction 1 or direction 2 or multiple directions, that is both side. So I will choose both side options. Here because I have not ticked the tangent propagations, so sweep feature simply stopped here at the end of lines. So let's turn on and see what happened. So because of these two combinations, we are able to sweep across the top surface. Just go ahead and click OK. So this way, using tangent propagations and both the directions sweep options, whenever your profile is exactly at the middle or maybe in the mid or somewhere along the path, it will offer you such options. Otherwise, naturally it is not available to you. In exercise 8.5, we are going to explore option called guide curves. Now, as we learned earlier, in sweep, the section which is called sketch profile remain constant along the path. But sometimes, let's say over here, this is the example of shampoo bottle, where the bottom section, which is elliptical, when sweep around, its dimension is also changing. If this is the requirement, then you have to use guide curve options. So guide curve is used when the cross section changes the shape, that you can say it's changing its dimensions. So it gives the better control over the outer surface. So guide curves is equal to extra sketch is controlling the sweep features. So it is more than the simply a path. So in this exercise, ellipse is our sketch. One of these curve is path and other remaining 3 are guide curves, as you can see on the slide. So let's try to explore. Now open the exercise 8.5. Here, the first I have created 2 curves. Second, 2 more curves on another plane. And third, the sketch profile. Now let's try to explore the guide curve option in swap features. So start it. Now let's select this sketch profile. Here, out of these 4, I will choose, let's say, this as a profile. Moment I do that, the problem is, along with this sketch, one more sketch geometry is added in a single sketch. So here selection toolbar asks me to choose either closed loop or open loop. So I will choose this and right click. Otherwise, it is not going allowed to select this individual sketch because 2 sketch geometry are in a single sketch. So I have to select them separately. So I have choose this one as a open loop. Now see what is outcome. Look at this. It simply follow the path and give you the sweep features. Let's go ahead and click OK. So this is not the desirable outcome. Now let's try to edit it. This time I'm going to add remaining 3 these curves as a guide curves. Now activate this and right click and choose this selection manager. Here I have to click on this open loop and click this and right click. Otherwise you are not able to add these part of a sketch under the guide curves window. Again, right click selection manager, make sure you have an open selection loop is turned on. Select this, right click, again right click selection manager, select this and right click. Now see the ellipse, which was earlier simply following the path, now it simply slide along the guide curves. As it does, its dimension changes. Look at very carefully. So this way you can simply use guide curves to control the size of a profile along the path. Now here you have an option to order. You can move up, move down. Because our shape is more is organic and symmetric about 2 sketches. So changing the direction or the sequence of a loop does not give you the change in the shape. But in reality, if you change the order of these guide curves, you may get the different outcome. So go ahead and click OK. Now in 8.6, we'll explore more options. One of them is align with end faces. Let's say I have a coffee mug here and I have drawn this path. And I will use a sketch over here to create a sweep features. The problem is sweep feature simply ends at the end of a sketch. So in this case, this handle will simply fail to merge with the body of a mug. So using this option called align with the end faces, it simply extend sweep feature to this surface and you will achieve the desired outcome. Open the exercise 8.6. I have created a coffee mug without handle, but for the handle I have a elliptical section and this path. So go ahead and click on sweep feature. Now under the sketch profile option, I will choose this ellipse as a sketch and this curve as a path. The problem is the end faces are not aligned. They simply terminate exactly at the location of where the path is completed, right? So they are remain perpendicular. Now what I want to extend these end portions. It's the same case at the top side. So edit this feature and expand these options and click on this align with the end faces. The moment I do that, let's see what happened here. Instead of terminating at the end of this path, it simply extend those end faces to meet the solid features. Go ahead and click OK. So sometimes these additional options in sweep helpful to create the desired results. Now if they were not there, how to achieve the same results? Then you have to extend these curves inside the muck, right, on the both ends. Or you may require to create the revolve cut. So the additional part of this handle will be removed and you will get the desired result. But we do not have to do that because sweep feature option is available. That is, now through exercise 8.7, we are able to explore the effect of profile orientation. Now what exactly it means? It says how should profile turn or rotate while traveling along the path. Here the first case is follow the path. So this is our path. It remain perpendicular to the path, right? It's simply following it. The moment the path turns, profile turns. So this is your outcomes. But in case of this option, keep normal constant, that means profile remain perpendicular to path irrespective of its change on path. So this is the outcome. If you look at very closely the end faces, you can immediately able to understand the effect of keep normal constant and follow the path. So based on the desired outcome, you have to choose this option of profile orientation. Even in that profile orientation, we do have called specified twist value, profile twist. So you can provide the degrees of rotation. So from starting point to the end point, if you provide the rotations, the sketch section get rotated and you will get this outcome. Open the exercise 8.7 where you can see two sketch are given. This is sketch profile and this is path. So start sweep feature. Select the sketch profile and path. Now instead going ahead and click OK, let's explore the options. Here profile orientation says follow the path and you will get simply this outcome. It remain perpendicular to the path. The moment it changes the direction, the profile also get, that is, it's aligned with the path. So click OK. So this is our first outcome. Now let's edit this part feature. Here instead of follow path, I will keep normal. Moment I select it, try to observe the end options. See what happened here. The section remain perpendicular to the provided path, no matter how it's changing, right? The orientation of path does not affect the orientation of simply the sketch profile. It does not turn along with the path. So here it remain normal. Keep the normal constant. Let's click OK. So this is the outcome. Now let's edit that part again. Instead of, I will choose follow normal, and here profile twist I will choose. I have three options: specified twist value, specified direction vector, and tangent to the adjacent face. I will choose this twist value. Again in twist control I have a radian, revolution and degree. Now I'll go for the first option called degree. Let's say 45. So it does, while starting from here and moving to the end, entire profile gradually rotated by 45 degree. This is the meaning of this twist angle. If you want in different direction, you can do so, toggling on this reverse direction. So based on this selection, you can either twist the profile on one side or other side. Now if you turn this keep normal, then result will also be little different because it's tried to keep normal. Through exercise 8.8, we will take advantage of this twist control to create helical spring. Here there are two outcomes. For this, I need to create a straight line which work as a path. And I will draw a circle which work as a sketch. So as I sweep along, I will twist the profile by revolution, and I'll give you the 5 revolutions. So this is 1, 2, 3, 4, and this is 5. Similarly, you can control through degrees instead of revolutions. So here I have provided 720 degree. You can provide any other values to get the outcome. So let's try to explore. Now open the exercise 8.8. Here I have drawn 2 sketch on front plate. First sketch one is simply a line of 100 millimeter which will use as a path. Second sketch on front plane is a circle of 6 millimeter diameter and at a distance of 20 millimeter. So our 20 millimeter is our average diameter of a spring. So start these swap features. Now because I have selected the circle, so it picked up as a sketch profile. Now for the path, I will choose these options, that is sketch 1, a path. Now here I will go here and select the twist value. Instead of degree, I am going to give you the revolution, 5 revolution. So this way you can create a helical spring with the option called profile twist and twist control. Go ahead and click OK. Now let's try to edit the features, and instead of revolution, let's try degree or radian. Okay, so this time I'm going to add only 360. That means what? For entire length, I have to twist the angle only for 360. This is called only 1 turn. So from here it goes 180 degree and then one other 180 degree means 360 degree. So let's double this value at 720. So it will add 2 turns. Let's add it and enter the value 440. So we have a 4 turns. So by using this option, either degree or either radian or revolution, you can control the twist of a profile. So you can create a spring, but you can also create a spring using this helix and spiral. Here we are able to create 3D helix curve, and then at the end of the curve we want to create a sketch, and that sketch will be simply sweep around a helical path. Now exercise 8.9 discuss the feature called swap cut. So instead of adding material, this will remove it. Now there is a stringent requirement of swap cut feature. Either you can use sketch profile, circular profile that we understood, or separately it required solid profile. So solid profile must be made from either by revolving the part like this, or it must have some kind of circular geometry. It should not be a part of a existing feature. So it should exist as a separate body. This is the requirement of solid profile. And other options are remain same. The only difference is it is going to create a cut instead of adding the material. So let's explore in SolidWorks. In this exercise 8.9, I have provided you 2 sketch. One is profile, second is path. Now swap cut feature is available in command manager at these locations. So start it. Now let's use the sketch profile option here. So I will choose this circle and I will choose this sketch as a path. Now focus on this right end. Moment I tick this aligned end faces, it align the end faces along with the existing face. Now let's go ahead and click OK. Now see, this is straight line and there is a curvature, straight line, curve and straight line. So in a sketch of path, straight line and arc are meeting over here. So it create a segment. How can I remove this? So edit this feature. Now here it is written merge tangent faces. So moment I click it, those part get removed. Let's say again, here our 4 circles are there. When I tick down, it removed. So same thing is exist in solid sweep features. So what it does, it simply allow us to create a smooth transitions by ignoring the individual segment of a sketch. So this way you can create a sweep cut in a part. Through exercise 8.10, we will explore how to use option called solid profile, which is available in 3rd positions. We already know how to use these first 2. Now remember, solid profile, a separate body, which is not merged with the existing part or features. Here there is a small cylindrical blue color cylinder is provided, should not merge with the existing solid part. Otherwise you are not able to use this option called solid profile. So here select a solid sweep along the path. There is a requirement over here. Now to cut it, so this cutting body will be referred as tool body. It is referred as tool body, just like a drill. So tool body must be convex like this. Its end should be convex and consists of one of the following: revolve feature made up of analytical geometry only such as lines and arc, or simply cylindrical extruded features, that is circle and extruded. So this solid body must be made from these 2 options. Otherwise you are not able to create the use a swap cut using solid profile. So let's see in SolidWorks. Now open the exercise 8.10. Here in this exercise, I have created a small base plate, then the path which to be used as a guide, and then I have created one feature using revolve. So if you look at very carefully, it is extending just inside the material, but it is not merged with the existing part. So here I have not ticked these options, merge result. If I tick this, it simply get added to the existing part. So it won't be a separate body. So you must use this untick this option called merge result. And because of that, we have a 2 separate body. One is revolve body, which will work as a tool, cutting tool body, and the other base body. Now let's try swept cut. Let's choose this solid profile. So here I will use this revolve feature as a solid profile. Now for the path, I have this curve. Here we have future scope called all bodies and selected bodies. Now option, because it says like this, because we have 2 separate bodies. This is base plate and second. If there are multiple bodies other than this base plate, you have to choose in which body you want to create the cut. So here it is called auto select is on, because our example is very simple. There is no other feature exists. So it will choose automatically to auto select and click OK. So it will create a cut, swept cut along the path. So this way you can create a cut sweep feature using solid body. So moment I did it, that tool body is consumed in cut sweep feature. So we have only one thing remain, that is cut sweep, because the before cut sweep let's roll back. We have a two solid body. So moment we use this cut sweep feature, it become the one body because tool is removed. It's a logical things. So cutting tool is get separated. Only one thing is remain. That's why we have the single body called cut sweep. So name is taken from the last feature we have used. Now let's practice the sweep feature. You have to build this model. I have provided you the sketch and this is your outcome. Here you need to be very careful how you create a 3D solid model, especially this part, right? So you have to use a simple sweep features. For that you have to create a path like this. From here to here is a line sketch and from here to here it is an arc and from here there is a line. So there are three segments, number 3, 2 and 1. And while creating it, we have given two separate diameter. One is 44, one is 60. Either you can subtract them and divide by 2 to get the thin feature thickness, or simply create two circles and use them as a sketch profile and sweep it. At the end, you can add this square plate, and in the top side, you can add the circular plate. So let's practice this in SolidWorks. Create a new part file. Now on a front plane, I'm going to create a path for sweep. So I will start from the line. And from here, I will draw the arc. And from there, I will use a line again. Now let's add the dimensions. So this is as given 80 millimeter. Radius of this arc is 90. And length of this line segment is 20. Also, the vertical distance is given, which is 75. So path is ready. Now let's draw on a top plane which is passing through this curve, this sketch profile. Here I will draw two circles. One having dimension of 60. Second is 44. And exit. Or you can press Ctrl 7 to arrange the sketch in isometric view. Now let's go ahead and use swept boss base feature. Here I have to use sketch profile and click OK. So again, let's go and edit it. Expand these options and click on this merge tangent faces. That means over here we saw the lines and that will be removed. Right? And now we have a very smooth transition of a shape. Now let's create the top and bottom part. So on this side, let's convert inside circle using convert entities and add the outer circle whose diameter is 90. Also add a construction circle whose diameter is given as 74, on which we are going to place the holes. So let's add a circle over here, small circle on 4 quadrant point as given in exercise. All of these having same dimensions, so select by pressing Ctrl and give equal constraint. Now provide the dimensions, which is 10. Now let's extrude. Now the thickness is not 10 but it is 12, so enter 12, and we are extruding in a right direction. Now let's add on bottom side the square part. So here let's use the center rectangle or midpoint rectangle and add the dimensions. Here it is looks like a square. So select this and make them equal and give the 80. Now either you can give the fillet feature right now in the sketch or later. So let's go ahead and add in sketch. This is 12. So use this part. Okay. This part. Okay. It's warning giving. It's give us warning. Let's select this and right click and right click. Here again, I have to choose this part to open this tube and use the convert entities. Now let's add circle over here, over here, over here, and last fourth one. Now all of these are equal. So select them and give them equal constraint. Now dimension is as given it is 10. So click on feature and click on extrude and it is 12 as given in exercise. Click OK. So this way you can use sweep feature to create the main body of a pipe and then add the end flanges. Now exercise 8.2. Just study the sketch very carefully. The bottom part as per the dimensions looks like a circular whose outer diameter is 90. The pitch circle diameter is 66. So do not confuse this 66 with the 68. Both ends are different. This is circular and this is like a pipe end flange shape. So here we have a 4 holes of 12 size and here we have a 10 millimeters. But how we are going to create this middle body? Just create first a small line like this, okay, and convert into construction geometry. Then add this arc up to this location and provide angle value to control this arc, and then add one more construction line of a 10 millimeter. Start new part file for the exercise 8.11.2. Now on a front, I will create that arc which required as a path for sweep feature. So I will choose line of a 10 value. Then I will add the arc. Then one more line. This line will be construction line. Bottom line will be a construction line. Now this line and this center should remain horizontal. Here I will draw one more center line to connect these two endpoints. Now I will give the angle value which is given as 45. And the center radius is 80. Now let's add the overall outside bend feature using sweep features. So exit from here. Now click on sweep features. Use circular part. If you study the sketch very carefully, this diameter is 30 and for thin feature the thickness is 5. Look at the sketch. On the top flange sides inside diameter is given 30. The central radius is 80. So 80 minus 15 will be 65 and inside radius is 60. So there is a 5 mm of gap. So let's select this curve and let's turn it on. So I'm giving the material on outside. So this is our 30 and this is 5. So go ahead and click OK. Now click on this bottom side. This time I am going to add a circle whose diameter is 90. Select this opening diameter and convert into entities. Again, draw one more circle and convert into construction and provide the dimensions. So it is 66. And there are 4 holes, each on quadrant point, as written in exercise. Now make them equal. Their value as given is 12. Now let's extrude on bottom side by 10 mm. Press Ctrl 7. Now let's create the remaining flange at this end. Select over here. Now convert this part, this inside opening circle, by using convert entities. Now let's draw a center line. Now let's add small circle of 10 mm. Now let's draw one more horizontal center line and create diametral dimensions of 68 as given in the sketch. Now let's add one more circle whose radius is 10, means total diameter is 20. Now let's add a circle over here whose diameter is 60. Now add the tangent line. Make sure having rubber effect. If it is not, just cancel it and try again. Yes, this is rubber effect. Again, try over here. Yes, this is tangent and coincident. So using mirror options, select this, right click, select this center line, vertical, and convert it. Let's try to mirror this part over here on a bottom side. So select the mirror sketch, this circle, this line, right click, and horizontal line, right click. Now let's trim the unwanted part. And this as well. Okay. So let's go ahead and click on extrude. Again, the thickness is 10 mm. Press Ctrl 7 and save your part. So by using sweep feature, you can create your part file.